Welcome to your Get That Nugget for GCSE Maths. Today we'll be concentrating on giving you a framework to answer questions about gradients of straight lines. This session is to complement your lessons with your teachers and is not to replace them in any way. Okay, so this session we're going to focus on looking at gradients of lines. Now you'll see here I've got a little bit of a notes section, and the reason for that is because I'm just going to show you a formula as such that can help us to calculate the gradient. Now, when we talk about gradients of a straight line, what we're talking about is the steepness of the line. So if we look at this graph here, we've got a straight line and our gradient is how steep this line is. Now, in maths, we have to calculate a numerical value for that gradient. And the way that I do it is using this formula, y2 minus y1 over x2 minus x1. In reality, it's probably not really a formula because we haven't got an equal sign, but this is a good way in order to be able to calculate gradients. Okay, now you may have been taught a slightly different method. You may have learned about rise over run. However, I find using this is really beneficial because you can use this when you have a graph, but also when you've got questions where you don't actually get given the graph. So when you've just got two coordinates. So let's have a look at example 1 then. Calculate the gradient of the line below. Now, as I said, we can use this to calculate our gradient. However, in order to do that, we need to figure out what y and x is. And the way we do that is we pick two coordinates. Now, sometimes you may get given the two coordinates, but if you have a graph like this, I suggest just picking two. Now, my suggestion is picking two that actually fall on a number point. So if I was to pick this point here, I can't get an exact value there. Whereas if I was to pick this point here, I can get an exact coordinate for that point. So I know this point, the coordinate is going to be 1, 3, along the corridor 1 and up 3. And then I need to pick a second point, and I'm probably going to go for, let's go for this one up here. Okay, now this point up here I know is along 3, and even though it doesn't say it on my y-axis, I know that my next value is going to be 7. All I'm then going to do, just to avoid doing my working out on the graph, is I'm going to write those points down. So I'm going to say 1, 3 and 3, 7. Now, it doesn't matter what way round you write them, you're always going to end up with the same answer. It just may be that you deal with a little bit of negatives, but when you divide through, you will still end up with the same answer. So I've written these two down, and the first thing I'm going to do is I'm going to label them. So I'm going to take my first coordinate, and I'm going to label my x value as x1, and I'm going to label my y value as y1. Like I said, it doesn't matter which way round you do it. If you did it the other way round, because of the division you do, you'll still end up with the same answer. Then my second one here, I'm going to label as x2 and y2. Now, using this here, I'm then going to calculate the gradient. So my y2 value is 7. Take away my y1 value, which is 3, over my x2 value, which I know here is 3. Take away my x1 value, which I know here is 1. 7 take away 3 then, that gets me 4. And 3 take away 1, that gets me 2. So what I end up with there is 4 over 2. Now, hopefully you know, but this fraction line also means that we divide. Now, because I can do this division, I'm going to do it. So because I can do 4 divided by 2 to get a whole number, we then are going to simplify it further. 4 divided by 2 gets me 2. So my gradient of that line is 2. Okay, let's have a look at another example. So calculate the gradient of the line below. Again, we've got a graph, and so we need to pick two coordinates. So the first one I'm going to pick, and the difficulty is here we're going to have some negatives, but we're going to deal with that in a second. So the first one I might pick would be this one here. And the other thing I need to add in is it does not matter which two coordinates you pick. You can pick any, like I said, as long as they are actually on a point of the square, and you will end up with the same answer. So this point here then, my coordinate is -2, because I go along -2 and up 3, so -2, 3. And then I am going to pick, let's go for this one here. This one is going to be along 1 and down -3. So, like I said, let's write our coordinates out here so we're not doing our working out on our graph. Our first one was -2, 3, and our second one was 1, -3. Now, first thing I'm going to do, label my coordinates, x1, y1. Remember, this is our x value, so that has to be the x1. This is my y value, so that has to be the y1. And then x2, y2. Now our formula, y2 minus y1, so y2 is minus 3, minus y1, which is 3. And then we've got x2, which is 1, minus x1, which is minus 2. This is where we just need to be really careful with our negatives. Always think about it. We're doing our x2, which is 1, take away, and then whatever our x1 value is. So we end up with a double negative here. Let's have a look at this then. So minus 3 take away 3, that's going to get me minus 6 over 1 minus minus 2. When we have this double negative, this turns into an addition. So this becomes 1 plus 2, which is 3. Then we're left with minus 6 over 3, and I can do that division. Minus 6 divided by 3 is going to get me minus 2. So my gradient there is minus 2. Now if we have a look at, if we can, both of these side by side, so you'll see this graph here, we had a gradient of 2 and we notice our line goes upwards. You'll notice this one, as the line goes down, we've got a negative gradient, okay? Okay, let's have a look at example number 3 then. Calculate the gradient of the line that passes through the coordinates 4, 6 and 7, 12. So this is where our y2 minus y1, x2 minus x1 comes in really, really handy, because we haven't got a graph to be able to do rise over run. So let's label them first and foremost. So our first one is going to be x1, y1. My second one is going to be x2, y2. Then I know my formula. My formula is y2 minus y1 over x2 minus x1, okay? y2 then is 12, take away my y1 value, which is 6, over x2, which is 7, take away my x1 value, which is 4. All I'm doing is I'm just substituting these values in. 12 take away 6, that gets me 6, and 7 take away 4, that gets me 3. 6 divided by 3 gets me 2. Okay. Okay. We've got another couple of examples here. So example number 4, calculate the gradient of the line that passes through the coordinates. So again, our first step, label them x1, y1, x2, y2. Remember, we're going to use y2 minus y1. So my y2 is 5 minus my y1, which is minus 3, over x2, which is 2, minus x1, which is 4. Remember, this double negative here becomes a plus, so this becomes 5 plus 3. 5 plus 3 gets me 8, and then 2 take away 4 gets me minus 2. We can then simplify that, so we're going to do 8 divided by minus 2, and that's going to get me a gradient of minus 4. Okay, remember, a positive divided by a negative gets us a negative number. Okay, example number 5 then. Calculate the gradient of the line that passes through the coordinates 1, minus 4 and 6, 3. Again, our first step, label our coordinates x1, y1, x2, y2. To calculate our gradient, we're going to do y2, 3, minus y1, my y1 is minus 4, divided by x2, which is 6, take away x1, which is 1. Okay, then we do this. Remember, our double negative becomes a plus. 3 plus 4 becomes 7, and 6 take away 1 becomes 5. Now, what you'll notice here, hopefully, 7 over 5, that is not an easy division for us to do. It is going to result in a decimal. If you calculate something like this, doesn't necessarily mean you have got it wrong. We've definitely got it right here. You can potentially calculate it as a decimal if you have a calculator. However, if this is on a non-calculator paper, all you are going to do is you are just going to leave your gradient as a fraction. We can absolutely leave our gradients as fractions, and so in this case, I would leave my gradient as being 7 over 5. Okay. There are 3 examples here for you to have a go at. None of these have graphs, so you need to be making sure you are doing y2 minus y1 over x2 minus x1, but have a go at those 3.